Alright, video number 2 for Monday. How to find x-intercepts when it does not factor nicely. So I've already written quite a bit on this slate here. Let me try and explain it. I gave you the general equation again for a parabola, which is y equals ax squared plus bx plus c. I gave you an example, 2x squared plus 8x plus 2. Now in this example, if you wanted to try and factor it like we did in the last video, I didn't mention this last time, but to factor, it's way easier if a equals 1, meaning that it's just an x squared, not 2x squared or some other coefficient other than 1. So to factor this, you would want to try and pull out a 2 from all three of these terms. Basically, the opposite of distributing. Pull that 2 back out. So that's what I did on this second line here. I pulled a 2 out, and now it's x squared plus 4x plus 1. If you distribute that 2 back through, it would look exactly like this line. Now you can try and factor what's in the parenthesis. What two numbers multiply to give 1 and add to give 4? Well, the only thing that multiplies to give 1 is 1 times 1 or negative 1 times negative 1, and neither one of those add to positive 4. So you can see that factoring isn't going to work in this example. So I'm just going to go ahead and erase that line because we're not going to use that. It's always good to check that because factoring is always the quickest, easiest way, but it doesn't usually work, unfortunately. So factoring is not going to work in this problem. So what we're going to have to use is this crazy looking formula over here, the quadratic formula. And it's got a bunch of B's and A's and C's in it. So I went ahead and wrote down A, B, C over here so that it might be easier to know what number gets substituted in for what. But where I'm going to get my A, B, and C is just from these numbers right here. So A is the number in front of x squared, that's 2. B is the number in front of x, that's 8. And C is the number by itself, that's 2. So you don't have to do this step. The numbers are already right there in front of you. But I found that for a lot of students, it's helpful to write down before you get started what A, B, and C actually are. Now you can substitute those into this equation. So I'll go ahead and do that, and then I'll show you the slate. So negative B would be negative 8, plus or minus the square root of 8 squared, which is 64, minus 4 times AC. I was going to do the math in my head and write these numbers down, but instead of writing 64, I'll write 8 squared minus 4 times 2 times 2, because A and C are both 2, divided by 2 times 2, because A is 2. So your next line, if you substituted in for A, B, and C into that equation, it would look like this. Now you can start to simplify this. So inside of your square root, you have 64 minus 16, and on the denominator you have 4, and then 64 minus 16 is going to be 48. So you're going to end up with negative 8 plus or minus the square root of 48 over 4. Now, that's not exactly a number. You know, that, like we said in factoring, what is the x-intercept? It's something comma 0. It's the point on the x-axis where the line crosses the x-axis, where the parabola crosses. So you wouldn't really plug that in right here and say, that's my ordered pair. That's not really a point. And if you solve for this on the calculator or you solve for this on Desmos.com, it's going to give you a decimal number here, a number with a bunch of decimals after it. So how do we condense this even further? Well, you want to separate it into two separate problems, basically, because of this plus minus. One of your problems is going to be negative 8 plus the square root of 48 over 4, and your other x-intercept is going to be negative 8 minus the square root of 48 over 4. So I will do that over here since I'm running out of room. So we'll say negative 8 plus the square root of 48 over 4. And then I'll do negative 8 minus the square root of 48 over 4. So I tried to squish them into there. So I separated into two problems, negative 8 plus and negative 8 minus. Now the square root of 48, to break that down, that's kind of a whole lesson in itself, and I don't want this video to go too long. But basically, you would prime factorization, the prime factorization tree, you would break down what two numbers multiply to give 48. And when you get all the way down to a bunch of 2's and a 3, you should end up with 4 2s and a 3, because 4 2s multiplied in a row, 2 times 2 times 2 times 2 is 16, and 16 times 3 is 48. That would get you back to where you started. So 4 2s and a 3, and whenever you have a pair of the same number, that's a whole number outside your parenthesis. So you'd end up with 2 pairs of 2. You have 4 2s, so one whole number 2 plus another whole number 2 and a 3 inside the square root. And when you have more than one number outside the square root, they get multiplied together. So it's basically 4 square root of 3. Sorry, that's hard to explain without showing you the math, so we'll have to do that in a different lesson. But essentially, this breaks down into -8 plus 4 square root 3 over 4, and this is -8 minus 4 square root 3 over 4. You just have to trust me right now if you don't understand why the square root of 48 breaks down into 4 square root 3. I'll try and explain that on paper a little bit better than this video. Now you can simplify this. A common mistake here is on this line before you break down the square root of 48 is people want to reduce this to 2 over 1 because 8 over 4 reduces to 2 over 1. Well, now you have 2 terms in the numerator, so you can't reduce with the denominator unless you reduce both the terms in the numerator with it. So here, the square root of 48, another common mistake, people want to do -2 plus the square root of 12 over 1 because 4 reduces with 8 and 4 reduces with 48 to 12. No, can't do that either. Think of a square root as almost like a variable, like an x, and whatever the coefficient of it is, whatever the number is, the whole number in front of the square root, that's what you would reduce the whole number with in the denominator, and it's only a 1, and 1 and 4 don't reduce. Well, now down here it's a 4, so now the 2 whole numbers in the numerator will reduce with 4. So now you can reduce this to -2 plus 1 square root 3 over 1, which is just -2 plus the square root of 3. The 1 goes away in front of the square root of 3, and the 1 we don't need in the denominator. Anything over 1 is just itself. So this is -2 plus the square root of 3, and the square root of 3 is like 1.7 something, 3 or 8, somewhere in there. So it's basically -2 plus 1.7, which would be about -0.3. Now, if some of you are using a calculator or Desmos, like I said before, you'll get something real close to -0.3. And then over here, you are subtracting. So this would be -2 minus square root of 3, which is -1.7. And when you subtract the negative from a negative, you get a bigger negative. So that would actually be like -3.70. So those would be your 2 x-intercepts in this problem. If you're using the calculator or Desmos, you get decimals that look like this. If you're doing it by hand on a test, that's going to be your answer right there in the box. Just -2 plus the square root of 3. They're going to want you to simplify it all the way down. If you just stop at this point right here, you're not going to see that as one of your choices. That's not simplified all the way down, unfortunately. I'm sorry. You're going to have to do this work over here and get it to -2 plus the square root of 3. Now, you're probably going to need more examples of this. I wish if we were in the classroom, I'd just spend all class working out more problems like this so you'd get the hang of it. But the videos take up too much space, so I can't do a video that's super long. So you just have to re-watch this one if it's not making sense, and you can always email me with my school email address or through Schoology, and I can try and help and answer some of your questions. If I'm overrun with questions, if none of you are getting this, then I'll just post another video and try and explain it again, maybe a little bit better the next time. So hopefully this helps, and then you can do your homework, which are a lot of problems that are very similar to this.